By now we are aware of what exactly the concept of atomic number and atomic mass is. Atomic number is simply the number of protons present inside the nucleus of an atom, whereas the atomic mass is the number of protons and neutrons present in the atomic nucleus. So when we have to represent both these entities for an element, how do we write it? Is there a specific way for representing it? Yes. The chemical symbol of the element is written with atomic number at its bottom on the left side, that is in subscript. On the other hand, the atomic mass is written on the top left side in superscript. Something like this. The symbol of the element, its atomic number and its atomic mass. Now, how do we represent a simple element like carbon? That's right, something like this. The atomic symbol, that is C, followed by the atomic number 6 and atomic mass 12 at the respective places. Now what if it's another element, say chlorine? Something like this maybe? Yes, one type of chlorine atom can be represented like this. Why did I say one type of chlorine atoms? Are there more types of chlorine atoms? Yes, some chlorine atoms have 20 neutrons instead of 18 in their nucleus. Then how do we represent this type? Yes, just like this representation. However, we now need to understand what exactly that is. There are many such cases where atoms of the same element exist in different forms. These forms are called the isotopes. Yes, in simple words, isotopes are defined as the atoms of the same element having the same number of protons but different number of neutrons. Yes, same number of protons but different number of neutrons. Just as we saw in the case of chlorine, all the atoms have 17 protons, but a few of them have 18 neutrons while some others have 20. So these are the isotopic forms of chlorine. Similarly, several elements have isotopic forms. For instance, we have carbon with 3 isotopes. As we can see here, each isotope has 6 protons but different number of neutrons. One has 6, the other has 7, and the last one with 8 neutrons. We name these isotopes as carbon-12, carbon-13, and carbon-14 respectively. Now this was about the different forms of the same element. But what if I tell you that atoms of 2 different elements can have the same atomic mass? Yes. Let's understand this with an example. We take 5 different elements: sulfur, potassium, calcium, chlorine, and argon. Now, if you notice, in each case the number of protons and neutrons is different. It's 16 and 24 here, 19 and 21 here, and so on. That's right. However, the total number of nucleons in each sums up to 40. What do we mean by a nucleon? A nucleon is a proton or a neutron. Yes, each thing present in a nucleus is a nucleon. So the total number of nucleons in an atom is the sum of protons and neutrons. We can also say that the total number of nucleons in an atom is its atomic mass. Yes, understand this well. The total number of nucleons, which is nothing but the sum of protons and neutrons, is the same as the atomic mass of the atom. So coming back to our example, there are 5 different atoms here. Though the number of protons and the number of neutrons is different in each case, the total number of nucleons in each is the same, which means the atomic masses are the same. How? Yes, it's simple math. One of the sulfur isotopes that we have taken as an example has 16 protons and 24 neutrons. So the atomic mass of this isotope has to be 40 units, that's 16 plus 24. Next is the potassium isotope having 19 protons and 21 neutrons. So again, we get the atomic mass as 40 units. And similarly, we get the atomic mass as 40 units in each of the remaining cases. Such atoms, or rather isotopes of different elements having the same atomic mass, are called as isobars. The term arises from Greek, iso meaning same and baros meaning weight. Remember, if we consider 2 isobars, the number of protons and number of neutrons in each case will be different. But the total number of nucleons or the atomic masses will be the same. So far, we've understood subatomic particles and a few important concepts related to atoms. Now, let's move ahead and learn the important concept of valency in the next lesson.